This is a topic from Math 1 that I'm sure you have not done since Math 1, Chapter 8. It's been a really long time. So we need to review it. So the first thing I want to remind you is exponentials are y equals ab to the x. And the easiest way to find a and b is to make a table. So I use the table method. There's a systems method that works also, but I like the table method the best. Okay, what you need to do is put your 2 points in the table. And you need to make sure that you have a spot for 0. In this particular problem, that's easy because the numbers go from -2 to 2. But if they don't, like these two, we have to make a spot for 0 in our table. So -2 is 3,200 and 2 is 12.5. Okay. Next thing you do is you count how many bees it takes to get to the center of the Tootsie Roll Pop. No. How many bees it takes to get from the top to the bottom. So 1, 2, 3, 4. It takes 4 multipliers to get from -2 to 2. Okay, so you write an equation, 3,200 b to the 4th, and it's the 4th because there's 4 b's here, equals 12.5. So 3,200 times some number times some number times some number times some number is going to be 12.5. Okay, now divide by 3,200 on both sides. And you're going to get a really terrible decimal, and you don't really want to round these. Okay, now how do I undo the 4th power? Root 4, 4th root. Yeah. Okay, so you write it like this. You write a little 4 with a root and a little 4 with a root. Okay, and then let me teach you how, so that it might be your first use of a graphing calculator with roots. If you hit the math button where it seems to be everything is located in your graphing calculator, you've got one called X root. Just scroll to that guy and put a 4 in there, and then the decimal. Now, Cody, I see your calculator is a little different from mine. You have to hit the 4 first, then X root, and then do the decimal, and it'll plug the little 4 in the X. Do you see what I'm saying?
Yeah.
Okay, so for Sean, also for you, you're going to want to do 4 first, then math, then scroll down to the X root, and it's not going to look on your calculator like it puts the little 4 there, but I promise you it will. And then just scroll up till you get that horrible decimal, or type it in, either way. Sean, do you have it?
Yeah.
Okay. All right, so that means the multiplier is 0.25, and then what you do is you multiply down the table till you get 0, whatever's next to 0, that's your start. So 3,200 times 0.25 is 800. I don't really know why I did that on a calculator, times 0.25 is 200. So A equals 200. You guys see where I got A from?
Yeah.
Okay, so then final answer, y equals 200 times 0.25 to the x. Okay, now on number 14, notice the points go from 2 to 5. So you have to backtrack your table so that you have a spot for 0 because that's going to be what A is. So you have to make sure that you have a spot for A. And then put in the rest of your table. Okay, how many B's are in this one? Yep. 3 B's. 140 B to the third is 112. This one's going to have a weird answer. I'm just going to warn you. Some of the time they have weird answers. It doesn't mean you did anything wrong. Is it not bad? Oh, okay. Well, B to the third is 0.8. But what's the cube root of 0.8 is the question. Yes, okay. However, for those of you with the older calculator, there should be a spot if you want to just do cube root, you should go down to number 4 instead of number 5. Just for my laziness purposes. Yeah, it's bad. So we're gonna go 0.93. So I guess I said don't round. What I mean is don't round until the end, like the last thing. Because like these roots won't come out nice if you have the wrong, like a rounded number in there. This one's not going to come out nice anyway. Okay, so what you want to do is divide by 0.93 to go back up the table. So you multiply to go down the table, divide to go back up the table. So 140 divided by 0.93, 150.5 divided by 0.93, 161.9. So A is 161.9. So Y equals 161.9 times 0.93 to the X. Okay, just take a look through that. You have any questions about that? It's old. It's really old. It's in the dusty file cabinets in your brain somewhere in the back. Unless you had Mr. Jones and he does the systems method. But I don't know. I think this is simpler. What? Oh, I know. But for this, he likes the systems method. I think it's because if you're in his class in 8th grade, that means you're advanced. So he's going to do it the advanced way. But anyway, so, okay. Now, if you could find the page in your packet that says 2-70. Yeah. It's right after the digital escape. So we're going to do half of this in the packet and half in the notebook, but it's going to start in the packet. And this is the first bit of math 3 for this chapter. Everything else has been reviewed, yeah. Okay. So, yeah, this is new. I know. Okay. So, this is something that you don't know yet. I need to teach you. I don't think it's terribly difficult. But this piece of it is an investigation piece. So, we're looking for a pattern. So I just want you guys to keep your eye out for a pattern. Okay, so f of negative x. What we're going to do is take each one of these and we're going to take this and take all of the x's and replace them with negative x's. Okay, So f of negative x equals negative x. Okay, let me say that again. I'm taking all of the x's in my parent function and replacing them with negative x's. No, now we're going to do each one separately. Okay, in this column, we're going to do -1 times the original. So -1 times x. I basically just putting a -1 times in the fronts of both sides. Okay, and what you're looking for, you're trying to find stuff that matches. So I'm going to go to a highlighter and I'm going to say, all right, this and this match. It makes a thing. There's a thing. It does a thing. Yeah, you're this is the first time you've ever this is new. Very new. Okay, x squared. So I'm going to take both of these and replace them with negative x, but I'm going to put it in parentheses. So f of negative x equals negative x squared. So I'm taking the x and replacing it with negative x. Okay, now what's a negative times a negative? Positive. Okay, now -1 times the original equals -1 times x squared, which is negative x squared. Okay, what matches in this line? These two, the original and f of negative x. You probably didn't realize that the original was one that you could actually check. Okay. Okay, f of negative x equals negative x cubed this time. Okay, it's a negative times a negative times a negative is a negative. Okay, so -1 times on both sides. Negative. Okay, what matches? Columns 2 and 3. Okay, so I took negative x, I replaced it. And what's the absolute value of a negative? Positive. -1 times the original. And the negative is outside. So it's negative. So this one, the negative was on the inside, which makes it positive because it's absolute value. This one, the negative is on the outside, so the negative stays outside. Okay, what matches? Yep. Yep, first and second. Yep. Okay, but you're getting the hang of it, I hope. Okay, so next one. Replace both of these guys with negative x. Okay, and this one is weird. This would be I root X. So -1 times both sides. Negative square root of X. This is the first time that nothing matches. I know, it's so unsatisfying. I really feel like I'm doing something when they match, but this one they don't match. Well, it's not like you did it wrong. It's just they're not always going to match. The ones that match are special. Okay. So here and here, I'm going to replace both of those with negative x's. Okay, and then I hate this. So I'm going to move the negative out front. Second and third match. Okay. Now this one, I put the negative x in the exponent, and remember, negative exponents go downstairs. And this one's literally just -1 times 2 to the x. And again, we have nothing matching. Okay, so we need to make some conclusions down here. Can you guys tell me the two that had matching in column 1 and 2? Yeah, x squared. Column 1 and 2 matching. Column 1 and 2 matching was x squared and absolute value of x. These are called even functions. Okay, pause there. I want to show you both of those on Desmos, although you saw them on your parent graph summary thing. Hold on, my computer's all in the wrong spot. Even, yeah. Okay. There are the graph of x squared and absolute value of x, and they have something in common. What? The left, okay, they have lots of things in common, but you're right. That they have the same domain and range, you're correct, that's not what I wanted, but yes, they have the same vertex, that's not it either. I'm looking for symmetry. What is their line of symmetry? What is that thing called? The line of symmetry. What's the thing called? The vertical thing that you draw. The y-axis, thank you. I was looking for y-axis. Okay, so yeah, you were. Okay. So what you say is all have, I'm gonna scooch this down for my folks in the back. All have, it's called reflection. Perfect. You spent 2 minutes on reflection symmetry in math too. And you say on the y-axis, specifically has to be on the y-axis, the reflection symmetry. Okay, now that you've gotten the symmetry thing down, can you guys tell me the three that are match in column 2 and 3? X cubed, 1 over x are called odd functions. I'm just listing the parent ones, like the original. I asked which ones match in column 2 and 3. Those are the 3 that matched in column 2 and 3. Okay, so let's look at Desmos again. I'm going to turn these two guys off. Y equals x. It was x cubed. And y equals 1 over x. Okay, what is this? Search your math 2 brain. What is this called? Okay, but what do you notice? Okay, what quadrants are they in? Oh yeah, okay, okay. What does that mean if they're in opposite quadrants? Okay, what's another word that goes with reflection that you learned? Rotation. Okay, these guys have rotation symmetry. Okay, what kind of rotation symmetry? What degrees? 180 around the origin. Nice. You have all redeemed yourselves. Excellent. Okay. All have 180-degree rotation symmetry about the origin. Okay, and then the other two sad, non-satisfying. Yeah. We call those just neither, even, or odd. So we're just going to say neither. So you're going to have math problems that say, determine if this equation is even, odd, or neither. Okay, so what I need to do now, that was number 70. Now we're going to do number 71, which is actually going through the process of figuring out, like, yeah, which is which. When there's not just the parent graphs, when it's like anything. Okay, so now we're going to the notebook. When you're ready. (2-71). And I incorporated 2-71 as the notes in the same thing. So it's not 2-71 and then notes. It's just all one thing. Got it, Violet, honey? What do you need? Okay, you sure? Okay. Okay, so start with this. this. Okay, and then after you write this down, make sure that you have a graphing calculator. Today's the day, people. We're gonna graph graphs on the graphing calculator. Today's the day. Violet, why did your 2 become a 1/2?
Because the 2 wasn't working and it's like, just so many erase marks.
I see a lot of, yeah.
Like,
It's supposed to be a 2.
I know it was. I know it was. I
Okay.
just didn't know what to say anymore. Like, I was like trying to remember.
A 1/2?
Yeah.
Why would you make it more complicated?
Numbers smaller.
Oh, I see. Okay. All right. So even functions. So this is, we're going to write down what the algebraic definition is of a function being even. But what I want to remind you is this is column 1 matching column 2 in our resource page that we did. So this is saying they're even when column 1 matches column 2. Okay, and then they're odd when column 2 matches column 3. So they're even when column 1 matches column 2, and they're odd when column 2 matches column 3. Okay, graphically, reflection symmetry on the y-axis, it has to be. And that has to be. These questions are great. They're a little bit confusing at first, but what I really like about them is you can look at the graph to check your answer from your algebra. So if you're confused about your answer from your algebra, you can just quickly check the graph to see if you got the right thing. That's why I like problems where you can check your work before you move on. Okay. Here we go. Example 1 and 2. There's 3 of them. I did one that's even, one that's odd, and one that's neither, so that you'll see all 3 different possibilities. Also, if you're a person who likes to put your notes in a different color, I'm going to start writing in a different color in a minute. Okay. Every single one of these problems goes the same. The first thing you do is you say column 1, column 2, column 3. Do you know where I got those from? Okay. Column 1 is my favorite. That means that you just write the original down again. Everybody good? I love that one. Okay, now column 2. I'm going to put an arrow here because I want to show you where x is, and we're going to replace that with a negative x. But you have to be careful and do it in parentheses. So negative x squared plus 2. Okay, now a negative times a negative is a positive. So x squared plus, okay. Now, negative 1 times the original, you're going to go negative 1 and then parentheses and distribute. Okay, you do that bit. So you do column 1, column 2, column 3. Then you check for matches. Do you see matches? 2. And we make the conclusion that we think it's even. We're pretty sure it's even. Now, I could tell you I was pretty sure it was even because the exponent was a squared, which is an even number. Okay, now the next thing we're going to do for graphically is we're going to graph it on the graphing calculator. And we're just going to look at the picture and make a little sketch of it here to see if it jives with our conclusion. So you're going to go to y equals. And if you've got some stuff in there, just hit the clear button, which is over here. Just clear anything out that's in there. Who knows? Also, if you're using one of my calculators, you need to make sure that all of the plots on the top, none of them are highlighted. Okay, let me show you what I mean. Highlighted, not highlighted. Highlighted, not highlighted. Okay, if they are, then you hit enter on top of it. So scroll to it with the arrow keys and then hit enter and it will turn it off. So this is basically like it's on, it's off. So you need to all be off. Okay, so now you're gonna put X, which is right next to the alpha button. It says XT theta N. Oh wait, I just have to be in the Y equals X squared plus 2. Okay, and then hit graph and see what happens. If your zoom is different from mine, you can hit zoom 6 and it will give you the same screen as me. Didn't work? What did it say? Are any of your plots on? Okay. X squared plus 2.
You press that for X right there?
Yeah.
Okay. You press graph.
Yeah, yours is all zoomed in. There you go.
Oh, you can unzoom it?
Zoom 6 will get it back to the original screen.
Zoom
6, yep.
Okay, thank you.
Wait, Zoom? I need a Zoom?
Zoom 6, if it doesn't look like mine, hit zoom and then 6.
What is that?
The zoom is the middle and the top.
Oh, yeah. What the fuck do you do?
No. Wait, it's incorrect.
I've been saying what the butt too much. I know, I see it so much. I've been, what the butt? Is it so very? I feel like, what the butt? You know, what the butt? But I don't like. That one. I like that. Like it is. Like if I'm playing you a 10.
They like decentralized. Oh.
I don't know how to use that. Oh, no. We're not taking a test. Who held their hand up back here? Two, six. Okay. Okay. Now you know. Okay, so the question you're asking yourself is, if it's even, does it have reflection symmetry on the y-axis? Does this have the thing you graphed? Does it have? Yes. Okay. So do you see how my algebra matched my graph conclusion? Okay, so that's what you're looking for. You're going to do the algebra, and then you're going to check your answer with the graph. Okay. Okay, and then some of you, the same people who like try to sneak into their parents' closet and try to figure out what their Christmas presents are ahead of time, are going to graph it on at first and then spoil the whole fun. But no, you have to do the algebra first and then check your answer with the graph. By the way, I was on the phone with my sister and she was reminding me of this year when apparently my parents had wrapped all the presents, but I went in and like I was like a little kid and I like loosened all the tape on like the wrapping paper on just one side of each of the boxes so I could figure out what my presents were. But then on Christmas, like all of the flaps were undone so they could tell I had done it. I got in a lot of trouble. Okay. Original f of negative x, negative 1 times f of x. Original f of negative x, negative 1 times f of x. Okay, original is easy. Just from looking at the exponent, what do you suspect this might be? Looking at the exponent is an odd number, so I suspect it might be an odd function. Okay, now I'm going to take my other color. I'm going to point to what x is, and I'm going to replace that with negative x, and I'm going to do it in parentheses. Okay, how many negatives are in this problem right here? 4. Because there's 3 of them with the cubed, and it's a positive. I know what you meant. Positive. I knew what you meant. I knew what you meant. Okay, and then negative 1 times the original, I put negative 1 in parentheses. Negative times a negative is a positive.
So columns 2 and 3 match, so it's odd. By the way, I can't just answer these without screaming. It has to be odd. Okay, now let's go back to the fun of the calculator. Okay, so go back to y equals. You can clear it, yeah. Okay, and we put in the original one, so negative 0.5 x, and then the third power you get from this up arrow, it's called the caret. And when you hit the up arrow caret button, you say to the in your mind. To the third. What do you mean? Why don't you play with it? It's the same button as like the scientific calculators. No, it's just in the y equals, the first one. Yeah. Yep.
Okay, boom.
And then you check the graph. Does this particular one have 180-degree rotation symmetry about the origin? Yup. So it confirms your conclusion that it was off. Okay, now since I'm not that creative of a lady, the last one is clearly neither. Because I said I had one of each, but I want to show you why. So for me, especially when I was your age, I would have seen the x cubed and been like, oh, it's odd, and moved on with life. But this one is actually neither. So that's why I picked this one, because it would be very easy to just be like, oh, it's a 3, it's odd, but it is not. Okay. Original x cubed plus 2. Don't forget your parentheses, so negative x cubed plus 2. And this is a negative times a negative times a negative, which is a negative. Okay, now don't forget the distributive property here. Again, don't forget the distributive property here. Oh no, because of the distributive property, they're all different, which means it's neither. So you write neither, because they're not matching, very unsatisfying. Let's still graph it and see what happened. It's okay, so go back to your y equals with your newfound unleashed power of graphing, fast graphing. Put in x cubed plus 2. Remember the caret gives you the cubed.
Okay, and this one very specifically has rotation symmetry. It has 180-degree rotation symmetry, but it's not on the origin. It was shifted up 2 units. So it's not on the origin anymore. It has to be on the origin. See what I'm saying? It's not on the origin. Yeah. I know. It's just unsatisfying. Okay. Take a look at the stamp sheet side, please. Okay, do you guys know what the homework is? 76, 77, 79, 81. So I think I'll probably have time to stamp all 4 of these on Friday. 89 to 92? Or completing the square. You know, it's scary. Did you not like it last year?
I'm not